Hello to Mark uh, Mattiozzo. I'm not sure if I'm saying that right, but he's 22 years old and from Lausanne, Switzerland. Thanks for your question. He says, hello, could you describe one of the experiments you performed on orbit and what were the results? You know, there's so many things going on up here and they're at different stages, and doing several fluids experiments, some medical experiments, Earth observation experiments. There's some experiments running outside for solar observations and material exposure to radiation and vacuum. Did actually a cognitive perception experiment to see how our brain behaves in this zero gravity. There's something else that's looking at sort of like a Star Trek tricorder, really. It's been able to analyze samples on the spot using a portable device rather than having to take some samples of surface samples or air samples or whatever and bring them down to Earth to study later. Being able to analyze the composition of something on the spot is going to be a really important capability for the future. Well, there's so many, but let me pick one to tell you about that I'm working on now. It's a fluids experiment in the Japanese module. It'll be the first main experiment there. And it's called MACE. And what it is, it's looking at, it's called a fluid bridge. So this is a fundamental fluid physics experiment, but it also has amazing applications. Basically looking at a chunk of fluid, and the fluid's going to sitting between two metal cylinders. So it's a cylinder-shaped bit of fluid, and it's pretty big, so it's not something you could do on the ground because it would just collapse. Up here it can float and be a relatively large segment of fluid, and there's going to be heating between the two plates, and up here the surface tension is a very dominant effect in the fluids. Once gravity is not a factor, and with heating between these plates, there's going to be a fluid flow that's also carried by the surface tension. So it's a very fundamental physics experiment, but it's looking at how fluids behave with the driving force and with surface tension as the mechanism for a flow. Now, why is this important? For fundamental physics reasons, there's interesting things to understand there, but and I'm not a specialist in this area, but one of the really neat things about this is that we have a lot of things on the ground and in space that depend on pumps and systems that have electronics and sensors and motors to make fluids move around for cooling, for engines, for propulsion, and pumps can fail, and things with parts can fail, and this experiment has some possible applications for looking at how fluids can move or be forced to move just because of a temperature difference. And so we have temperature differences up here, very large temperature differences from inside to outside, from day to night, shadow and sunlight, huge temperature differences. And it's possible to generate flows of fluids just because of these temperature differences. You can imagine a cooling system that works on a space station for a mission to Mars, for example, with no moving parts. All it would have is tubes, and by exposing these tubes to heating and cooling, you would have the ability to generate a continuous flow without any power and any motor. So anyway, this is one of the possible applications for understanding these mechanisms better. So that's a pretty neat experiment. We're just getting started. We set up all the apparatus, and it's hopefully going to start in the next few days.
Gotcha!